Hello there and welcome to Nature with Earth, where curiosity gets cozy and science settles in for the night. Tonight's gentle journey whispers us back through the veils of time, to a place where the cosmos dreamed up worlds from whispers of dust. We're exploring the birth of our planet, its raw early history, and the quiet revolution known as the Great Oxygenation Event. Not just facts etched in stone, but a lullaby of origins, where every rock holds a secret and every wave remembers its first sigh. Have you ever paused in the hush of evening and wondered what stirred before the first dawn? Before rivers carved canyons, before winds whispered through leaves, before the very air we breathe was born? Imagine the floor beneath you, steady and familiar, once a seething cauldron of fire and stardust, a newborn world tumbling into existence. It's a curious thought, isn't it? That the same earth cradling your home, your footsteps, your quiet dreams was once nothing more than cosmic echoes, and then, in a blink of eternity, it was everything. But before we wander into that ancient haze, I'd love to know, where in the world are you listening from tonight? And what time is it in your little corner of the cosmos? If this soft unraveling of planetary mysteries wraps you in even a thread of peace, I'd be ever so grateful if you gave it a like, perhaps subscribed, or shared it with a friend who's seeking a serene escape into science. It helps this tranquil nook find its way to others craving a gentle tale at day's end. So nestle in, let your mind drift like mist on a still lake, and let's begin. Because before there were forests or fireflies or forgotten legends, there was only silence and scattered dust. And from it, somehow Earth awoke. About 4.6 billion years ago, in the swirling chaos of a fledgling solar system, a miracle of gravity and grit unfolded. A violent ballet of collisions, molten rock, and unrelenting pull birthed the planet we call home. The one holding you now, in this very moment. The ground beneath us is ancient beyond reckoning, older than whispers of life, older than the stars we wish upon. Yet its tale is still being written, pieced together from clues hidden in stone and sky. Sometimes, to grasp the distant past, we start with a puzzle in the present. In the late 1960s, geologists wandering the arid expanses of Western Australia stumbled upon something peculiar. Smooth, rounded pebbles nestled in rust-red rock, like secrets tucked into a forgotten drawer. These stones resembled river-worn gems, shaped by flowing water, but the surrounding rock dated back nearly 3.5 billion years. How could rivers have danced so early? Was there land to cradle them, oceans to feed them? Could Earth have harbored liquid water before life even flickered into being? That humble discovery, the curve of a pebble, pried open a grander enigma, one demanding years of dusty fieldwork, heated debates, lab analyses, satellite gazes, and boots caked in earth. What was this primordial Earth like? If you could stand upon it, what would it feel like underfoot? And how exactly did it emerge from the void? Leap forward to a quiet lab in California, where a scientist peers into the heart of a zircon, a resilient mineral born in fiery melts, guarding secrets like a crystal-bound journal. She examines the isotopes within, tracking the slow decay of uranium into lead, an atomic clock not marking minutes but millennia. From a grain tinier than a speck of sand, she uncovers a revelation. Earth was forging its crust, its solid skin, a mere 160 million years after the solar system's dawn. That's swift in cosmic terms. Earth, eager and bold, hurried to become itself. But let's pause and rewind, to envision the solar system before it earned its name. No orderly planets, no loyal moons, no graceful orbits around a steady sun. Just a vast, spinning cloud of gas and dust, the remnants of elder stars that had blazed, burst, and strewn their essence across the void. This solar nebula stretched immense, a nebula of possibilities. Slowly, inexorably, gravity coaxed it inward, spinning faster like a figure skater drawing in her limbs. At its core, heat swelled until hydrogen fused, igniting the sun's primal flame. Around this infant star, the scraps formed a flattened disk, a cosmic platter of tiny grains swirling like flour in a beam of light. Dust gathered to dust, birthing pebbles. Pebbles merged into boulders. Boulders collided into planetesimals, those baby planets stumbling through space like cosmic toddlers, clumsy and full of potential. It was no tender cradle. It was thunderous, scorching, a frenzy of impacts. Yet from that turmoil, harmony bloomed. Earth emerged not as a polished gem, but a glowing sphere of molten rock, its surface a churning sea of lava, pummeled by relentless barrages, some as grand as mountains, others rivaling Mars itself. Yes, Mars. For soon after Earth's rough shaping, a rogue planet, perhaps Mars-sized, careened into it at a precise angle and velocity. Not to shatter, but to transform. It sheared away a colossal fragment, vaporizing rock and metal into an orbiting ring of debris. From that fiery birth, the moon coalesced, a child of collision, nurtured by gravity's embrace. We know this from more than fancy. Lunar samples reveal compositions mirroring Earth's mantle, orbits and tilts bearing the scars of that ancient clash. Dubbed the Theia collision, after the mythic Moon Mother, it didn't merely gift us a celestial companion. It remade Earth, perhaps stripping a stifling early atmosphere, quickening its spin, leaving a seething, molten world desperate to cool. How do we unravel such tales? Mostly from rocks, those silent chroniclers. The eldest survive in Canada, Greenland, and Australia, where archaic crust emerges like ancient tomes from buried shelves. They murmur through isotopes, mineral grains, oxygen balances, and leads decay, painting a portrait of a treeless, lifeless realm of firestorms and ceaseless cosmic hail. Then, abruptly, water. Its origins remain a gentle mystery. Perhaps comets, those icy wanderers from the solar fringes, delivered it in cataclysmic gifts. Or volcanic outgassing, where Earth's watery innards exhaled through eruptions, condensing into clouds and relentless rain. Either path led to darkened skies, cooling steam, and precipitation that poured for eons, swaddling the planet in vast storms until it became an ocean world, seas without shores, waves unbroken by land. We're uncertain how long this submerged era endured. Some whisper of volcanic protocontinents, rocky isles piercing the floods. Others envision total immersion. But plate tectonics soon awakened, slabs shifting atop a yielding mantle, birthing continents from the deep. This is the marvel. We've gleaned it all from whispers, a zircon speck, an ancient pebble, a lunar wobble. Science treads softly, peering intently, attuning to the stones. Consider Harrison Schmitt, the sole geologist to tread the moon during Apollo 17. His lunar soil samples bolstered the Theia theory, revealing Earth fragments ejected in the impact, preserved on the moon, a museum untouched by erosion or tectonics, archiving our planet's lost infancy. Deeper clues lie in Earth's magnetic field, spun from a liquid iron core that churns like a hidden heart, warding off solar winds and radiation. This core formed through differentiation. As the cooling Earth sorted heavy iron and nickel to its depths, layering core, mantle, crust, granting structure and a protective magnetic umbrella for atmosphere and life. Meteorites echo this too, iron-rich relics from shattered protoplanets, like holding Earth's core frozen in time since the solar system's cradle. And life? Earth's violent forging paved its path. Stable crust, water's embrace, magnetic shield, moon's steadying tug on tilt and seasons. All improbable ingredients for biology's recipe. Earth might have been diminutive like Mars, losing its air, or spun wildly, or missed Theia's kiss, or shattered in another blow. Yet here we linger for 0.6 billion years on, attuned to its saga, all sparked from dust. Pause now and picture Earth unseen. No verdant hues, no avian calls, no azure skies. A colorless realm, or rather, one of raw tones, red-orange veils of carbon dioxide and methane, smog-shrouded, steaming from nascent oceans. Molten rock cooled to jagged scabs, only to fracture under impacts, lava tectonic size. Volcanoes burst from fissures, the planet exhaling birth heat. Rain fell not softly, but in ceaseless deluges, epics of storm defining the world. Oceans formed, acidic, mineral-laden, stirred by lunar tides and asteroid waves. Beneath, hydrothermal vents spewed hot, rich fluids, where chemistry may have whispered life's first notes. Molecules mingling with metals, heat, time, birthing replicators. Plate tectonics danced early, slabs drifting, colliding, reshaping atmospheres and seas. The planet cooled reluctantly toward stability. Rare survivors like Canada's 4-billion-year-old Acastan ice, a time capsule of nascent solidity, or Jack Hill's zircons in Western Australia, revealing water just 150 million years post-formation. Earth's Goldilocks zone, neither too hot nor cold, ensured water's liquidity, sculpting, dissolving, nurturing. Its size retained air, core birth magnetism, moon-stabilized spins. Life transitioned subtly, perhaps in vents or pools. Simple cells replicating, evolving in iron-murky oceans under radiation-pierced skies. Stromatolites, microbial towers, emerged, pioneers in primitive photosynthesis, eking oxygen as waste. They transformed unwittingly, rusting oceans into banded iron formations, red-black stripes of ancient rust. Yet oxygen amassed, triggering the Great Oxygenation Event around 2.4 billion years ago. Cyanobacteria, those blue-green microbes, harness sunlight, expelling oxygen that first oxidized oceanic iron, forming those formations in Australia and South Africa. Fingerprints of molecular shift. When iron waned, oxygen seeped into air, a toxic tide for anaerobic life. It ravaged proteins, DNA. Ecosystems collapsed, microbes fleeing to shadows. This silent apocalypse reshaped Earth, paving for oxygen breathers, ozone shields, complexity. But that's a tale for another eve. For now, dwell in this primordial beauty, not floral grace, but raw power, honest flux. A world of simmering seas, volcanic roars, chemical hums. Earth was alive in its essence, pulsing before biology. We, its heirs, carry star-forged elements, lava-born minerals, moon-ancient waters. In stillness, hear its breath, the ocean sigh, plates murmur, a deep, living rhythm. Change storms in unbidden, as oxygen did, remaking all. Perhaps next, we'll chase life's next leap. Until then, rest well in Earth's embrace.